Hi guys, welcome back to NunleyMath. I'm Aaron Nunley. Thank you for joining me for today's Professional Development Series topic number 2. What are some strategies for helping students break down word problems? Now this is a question I get a lot from a lot of different teachers as well as parents and students because let's face it, most of us really have struggled with word problems. And I think a lot of this has to do with how word problems have been taught to us as adults. Back when we were in school, some different approaches and methodologies that were implemented back in the 70s, 80s, and 90s that may not have been as effective as we would have liked. A lot has changed in terms of how we teach students problem solving. And so I just wanted to share with you a couple thoughts that seem to have helped me in my class, and I hope they will help you as well. So let's dive right in. Number one, the biggest thing I think we need to make sure that we do when we're talking about word problems is we need to address the elephant in the room. And that is that by and large, word problems are more difficult than simply solving traditional math problems. A lot of times as teachers and parents, we look at students and we say, oh, why can't you get this? This is easy. And in reality, it's not easy for the students. Sometimes we have all this background information and points of reference that we bring into the problem that they simply don't have as they're approaching it. So it's not necessarily easy for them. In terms of brain function, there's a lot more processes involved than there are in just solving a written out problem. Students have to learn how to evaluate, analyze, and interpret rather than just simply recalling a formula or a calculation. So it is legitimately a more difficult topic and scores higher on Bloom's taxonomy. Lastly, we need to acknowledge that solving a word problem is an entirely different skill set than solving a algorithmic type problem in class. It may not come naturally for students, especially if the students have not had an opportunity to explore, examine, or discuss math in their previous content. So let's acknowledge that at the beginning. It is difficult, and we need to be honest with our students about that. It's important for us as teachers not to try and persuade students that this is easy and make them believe that and therefore have the problems be easier, because when it's not easy, they tend to get frustrated and overwhelmed and angry at themselves and have some negative self-talk. Instead, what we want to do is we want to acknowledge that it's hard so that when they struggle, they at least have the awareness that, hey, everybody struggles with this. I am not out of the ordinary. I'm not stupid. I'm not abnormal. And then when they achieve some learning, then they can feel that sense of accomplishment. Okay, strategy number 2. We need to make sure we're talking about vocabulary. And I know vocabulary has become kind of a sticky spot in modern mathematics where we want to focus on exploration and we want to focus on activities and trial and so on and so forth. But there are certain words that students need to be familiar with, and they need to have context for those. Math is a language just like English, and it's designed to make concepts easier to express in written form. So when I talk about a cat is an idea or an animal that exists in the real world. When I write the letters C-A-T, those 3 letters are not a cat. They are simply a quick and easy symbolic expression so that when somebody sees it, it brings that concept to mind. We need to think the same thing when we're talking about word problems. There is an English word that generally students are familiar with that communicates an idea that hopefully we have all experienced. The trick for us is to transition that idea from the word into the symbol. So for example, when we see the word combine in a word problem, that communicates to us, or should communicate to us, a particular idea. And that idea is putting things together. And once students learn to recognize the word combine as this concept of putting things together, then we can connect it to the plus symbol that you and I are probably familiar with. It is extremely important, though, to go through that process. What does it mean to combine things? Have the students talk about that with you. Oh, it's putting things together. Oh, we have a math symbol that means the same thing, and how do we write that? That's how we do vocabulary in a meaningful way, rather than just giving students a list of terms that they need to memorize. Here's another example. When we have this word remove, remove should communicate an idea to the student, and that is this idea of taking something away, which then of course math would use the symbol, the subtraction symbol to represent. Words like split. Split's a little harder to define. I went ahead and say to portion out or to break up evenly. And of course, you and I know that is the division symbol. Now, in my lessons with students, I go through multiple vocabulary words. I give them a vocabulary list they can refer back to when they're struggling to make the connection. I allow them to use that on their practice. And then hopefully by the time we get to the test, they've made a connection between the symbols and their meaning and are able to do it without that. When we're talking about vocabulary, it is important for us to recognize that we use specific words in math that are used differently than you might use them in the English language. I call these our special words. Just like in English, these words can make changes or adjustments to how we're talking. For example, the word than is a very, very powerful word in math. It changes the order of things, particularly dealing with order of operations or what order we list our numbers. If you think about something like 10 less 5, well, mathematically that says 10 subtract 5, which would be 5. But as soon as I stick the word than in there, 10 less than 5, I've reversed that and now I have 5 minus 10. That's something that often occurs intuitively to us as teachers, but for the student, you may have to explicitly state that. And I would actually say that the word than has caused my students more trouble over the years than just about anything else in this unit. It's also important for us to make sure that students look at verbs or actions differently than other words. Usually your verb in a sentence is an equal sign. I say that to teachers, and a lot of times the teachers get really thrown off by that as well. But if you think about a phrase like Tom ate 10 more than Bill, that verb ate, A-T-E, you might not at first think of that as being an equal sign. But what if I were to give the same statement this way? The number that Tom ate is the same as or is equal to 10 more than the number that Bill ate. At this point, we can begin to see the connection between the verb and the equal sign. This action is the same as some other action. Okay? And of course, in algebra, we would translate this to T, Tom, is equals 10 is the number 10, more than is plus, and of course, since we don't know Bill, it would be B. Notice I also snuck the word than in as well, so that it's not 10 plus B, it's B plus 10. Now, of course, addition is commutative, so it doesn't matter in this context, but I thought it was worth pointing out in this problem. We also want to make sure that we articulate to students that there are certain tricky spots that will come up when they're working in these word problems. For example, when I say Tom's age less Bill's, I mean T minus B. But when I talk about Tom's age less than Bill's, it's B minus T. And Tom's age is less than Bill's. Notice that verb snuck in there. That turns this into an equality symbol. T is less than B. We often take it for granted that students are able to differentiate between these statements. However, it's very, very useful for us to at least on a few occasions to show them the power of words like than and the power of verbs. I often will ask this same question multiple different ways where I'm using the exact same names, Tom, Bill, and then the same basic word like less. And then I rearrange it, I put in thans, I put in different verbs, I swap things up just to see if they're able to differentiate between those. Using the same variables and the same operations in multiple different ways forces students to really get particular and careful with how they are reading the problem. Strategy number 3, we need to teach students how to read. Teach students how to read. Now, as a math teacher, I often struggle with this idea of teaching students to read because I tell myself I have enough standards in my own curriculum without dealing with literacy standards. But as you all know, we are all reading teachers these days, and it's really important that we teach students how to read technical information in a way that's different than narrative information. For example, reading math is different from reading fiction or nonfiction. Oftentimes, students are going to read through their word problems or their application problems. They're going to do it way too fast to actually learn anything. Oftentimes, they're reading for words and not for meaning. And they often struggle to differentiate important and unimportant information. They often view each problem as unique instead of learning that a lot of times the same types of problems are being given over and over again. If we as teachers can enter into this unit knowing that students are going to struggle in those 4 particular ways, there are some specific things that we can do to help them. Number 1, we want to make sure when they're reading we give them a goal. We want to make sure they understand that they are looking for specific or particular things that they are going to miss if they do too much too fast. Number 2, we want to make sure that the students understand that the word problem is telling them a story. You'll find that often if you remove specific numbers from a problem or replace difficult numbers with easier numbers within the context or framework of the story, they'll often be able to figure out how to solve the problem much more quickly. We'll talk about that in a second. We want to make sure that students understand the difference between information that is only for context or story as opposed to information that they're going to need to use for their calculations and computations. And lastly, we want to make sure we talk about patterns. I'll delve into that here in just a minute. So this slide gives an example of how I teach students how to read in my class. Now it is going to get a little crowded, a little tedious, a little busy here for just a second. But I'm going to encourage you to hang with me because when I do this with my students, the first one's always a little bit messy because we're putting a lot of information together, and then we begin to look for ways to clean it up in the future. So just know I'm aware this is a little bit of a handful, but if you hang with me, I promise you it's going to be worthwhile. Let's take a look at the example. This is just an example like you might see in any 7th grade class. Dante works for a local software firm. He earns $5 more per hour than Haley and Malcolm combined. Dante earns $30 per hour. Haley earns $11 per hour. How much does Malcolm earn? Now, for a student reading that, what I'm going to tell them is when they read through that, they want to read it one sentence at a time, and they want to look for 4 particular things. Most application problems have 4 types of sentences. Number 1, useless information. This is context clues. This is creating the narrative. Not terribly important for us. There's useful information, and I'll talk with my students about the fact that useful information is often a number or a measurement. Third, we're looking at relationship sentences where 2 or more pieces of information that we might consider to be useful are compared. And lastly, we're looking for a question or a problem. Notice I've used the letters U, I, R, and Q given here in red to help delineate which sentence is which. Then I've gone through and I've rewritten the word problem so that we can see each sentence separately. Now obviously my students wouldn't do that. I would have them go through and circle and underline a label up here, but for our sake today this is going to be a little less messy. Let's read through these. Dante works for a local software firm, period. Notice I stopped here. This is the only sentence I'm concerning myself with at the moment. I want to look at this and I want to make a decision about what to do with that sentence. Am I going to get rid of it because it's useless? Hang on to it because it's useful? Is it giving me a comparison or a relationship that I need to work with? Or is it asking me a question or solving a problem? Hopefully you realize that this is a piece of useless information. Knowing that it's a piece of useless information, I'm eventually going to get rid of this. Now this second sentence says he earns $5 more per hour than Haley and Malcolm combined. I've gone through and I've labeled this as a relationship sentence. A lot of people call this an information sentence, but notice they're not simply stating a number or a fact. They're drawing a comparison between he and 2 other people. That elevates it from information to relationship. Dante earns $30 per hour. Haley earns $11 per hour. What do you think we do with this? I'm calling this information. Now it does give me 2 pieces of information, but it really doesn't draw any relationship or comparison between those, so I simply have 2 pieces of information. And of course at the end the question is how much does Malcolm earn? That is our question. Notice I've been able to identify all 4 of these within this one word problem. I would have my students go through and label these, particularly if they're students who struggle with word problems. So I'm going to eliminate the useless information. Dante works for a software firm, has nothing to say to us mathematically. It's just creating a context for the story. I then want to have a goal for this problem. Why am I reading this in the first place? The goal is always given to me in the question. The question is, how much does Malcolm earn? Because I'm in an algebra and a pre-algebra class, I'm going to assign that a variable, P being Malcolm's salary. Now, ordinarily, I would have made this M for Malcolm's salary, but I believe this was an old problem that used the name Pierce, and I've converted it, and I just forgot to change variables. It's a good time to talk about the fact that variables can be anything you want, but assigning them letters that have meaning to you as the problem solver is usually a good idea. Once I've done that, I want to tell the story. The story is the relationship that's given. It's going to lead us to our equation or our steps for solving the problem. Notice I've pulled that out. I would not make my students rewrite this, but for our sake, it's helpful. It says he earns $5 more per hour than Haley and Malcolm combined. Very important for us to know who he is. It's a great time to remind students that when you're reading and you come up against a pronoun, your pronoun must refer to an antecedent, and typically it's whatever you were just talking about in the previous sentence. Since he is here, in the previous sentence I was talking about Dante, so I'm going to replace that with Dante. Now that I have that, I want to read it again. Dante earns 5 more per hour than Haley and Malcolm combined. I want to tell that as a story. I'm making a comparison between Dante's money, and I'm saying that it is 5 more than Haley and Malcolm's combined. Very important the students realize this is a comparison between Dante's money and everybody else's. Once they realize that, we can begin to insert our information into this problem using translation and vocabulary that we talked about earlier. Okay, notice Dante's money. Do we know that? Well, yeah, Dante earns 30 every hour. Is my verb, equals 5, more than is usually a plus word. Haley's money. Do I know Haley's money? I'm going to go back and look at my, oh, I do. It's an 11. And it's combined with, that's a plus, and we have Malcolm, which I have labeled M down here. You'll notice I need to change that in my slideshow. Okay, again, by giving the students this goal, find what each sentence means, and helping them realize what each type of sentence does, we've taken what could have been an overwhelming problem and we've broken it down into pieces that are manageable for our students. Now, I know what some of you are probably already thinking. There are some times where the relationship is not given. After I've taught my students how to solve using this method, we talk about assumed relationships or relationships that the problem giver assumes that you know. This would be things like if the question says find the area. They may not state the area formula because they assume you know it. Work problems and distance problems are notorious for these kinds of assumed relationships, as are triangle sum theorems. Again, once my students are good at translating, then we'll begin to introduce problems with these assumed relationships. It's also important for your students to know that if they do not know what they are assumed to know, the problems become virtually impossible. If I don't know about the angles in a triangle adding up to 180, the problem will not tell me that, and I am instantly stuck. That's why I tell my students, when I give you a formula, you need to learn it, you need to learn it, you need to learn it. Okay? Strategy number 4, you want to teach the patterns. Students get asked the same types of problems over and over and over again, and we want to teach them to recognize that the same story is occurring and help them connect the new problem back to the strategies they used on the old problems. For example, if I were an elementary student, we would talk a lot about combining things. We might talk a lot about splitting things, removing things, averaging things. These are problems kids get asked over and over and over again. Arranging things. When they read the problem, they want to begin to take that problem and think about it in the context of the types of problems they've solved before. How is this the same as those? How are those different? For me as a pre-algebra and algebra 1 teacher, when I teach this, I teach these kinds of patterns. I teach them to first look for simple translations. I then talk about geometric formula patterns. If the problem says what is the area, you have an instant connection to what pattern you ought to be using. We talk a lot about proportion and percent patterns. We talk a lot about distance formulas and distance patterns, work problems and work patterns. Once the students have begun to look for types of problems or patterns, then it allows them to access strategies more quickly and easily. Lastly, strategy number 5, you want to make sure you're holding on to the expectation that students will learn word problems. We talked at the very beginning about the fact that the elephant in the room is they are harder, and a lot of times we as teachers, either knowingly or unknowingly, like to push them off to the side because we struggle with word problems as well. We struggle with how do I teach students to think critically, or how do I teach students how to break these down? I've heard teachers say, either a student can think this way or they can't. Well, that's not true. All students can think critically, but you have to give them structures and strategies in order to do that. Hold that expectation. Traditionally, we will teach our units something like this. When we do our instruction, we'll teach expressions, then equations, then inequalities, and then we'll do word problems. And when we generate our assessment, we'll probably make the assessment look something like this: 30% expressions, 30% equations, 30% inequalities, and then we'll tack on a few word problems at the end. The problem I have with this is, notice that word problems are only 10% of the focus of your unit. What you've told your students is this is the really important stuff you need to know, and this is not terribly important. And more importantly for your students, what begins to happen is they begin to realize, hey, if I know these skills really, really well, I don't actually need to know word problems. In fact, I've heard students say, when I take a test or when I do a homework assignment or a quiz, I do all the problems I know how to do, and then I skip the word problems at the end because it's only 1 or 2 problems and it's not going to affect my grade anyway. We have accidentally told students these are not important. Instead, you might consider a strategy more like this. Take those word problems, move them out of your unit on equations and inequalities and expressions. Reassign your point values so the expressions, equations, and inequalities are all 1/3 of your value apiece. Notice what you've told your students is you need to be able to work with equations and variables and constants and that sort of thing. And then in my class, will create an entirely separate unit on word problems because the strategies I use, the things that the students need to understand, are an entirely different skill set, and they are important. This forces students to not just learn the procedural stuff, but it forces them to be vested in the problem solving as well. Again, grading should not only assess student understanding, but it should also be set up in a way that motivates them to do better. That's all I've got for you. Again, thank you so much for watching. If you have any thoughts, things that I left out that I should have left in, any questions that I can answer maybe a little better, make sure you leave me a comment in the comment section. Also, if you have some questions or problems that you're seeing in class, some things students struggle with or you're struggling to teach, leave me that in the comment section as well. I'd love to address some of those for you in future videos. As always, I do wish you guys the very, very best. Take care of yourselves. Bye-bye.